So full disclosure, I'm working at Here Technologies. Maybe you have known us Here Maps or Nokia Maps even in the past. And we are now shifting to more technology company, different products and services. But yeah, now you all think, oh, this guy is going to sell the maps to us. No, I'm not here for that. I'm here to share my take on them, how to work with them and avoid common mistakes, so then you can switch between different map providers in a blink. So maybe this situation sounds familiar to you. You're one day in the office, comes your PO and says, hey, we got a super nice deal with this new map provider, and can we change it right away? And you're like, sure, let's try. So after a month, you're still on your code, finding that all the classes from the map are everywhere. Lat long here, map objects over there. So yeah, then it becomes a nightmare, actually, to do this refactor. So how could we avoid that? So actually, any external dependency or third party that we are normally using, we would anyways probably add some abstraction layer on top of it, because we never know when it will change, when what will happen with it. And we only need to apply some really similar rules that we apply on our daily life on coding. So I will focus on three, actually, principles on this talk. So single responsibility, immutability of objects and classes, and unidirectional data flow. In order to do that, I will go through an example that probably most of you have seen if you have ever worked with maps. So this is actually what you see on the Google web when you go in to introduce the Android maps. I just ported to Kotlin to make it a bit more readable. And it is simple, isn't it? You get your map fragment, you initialize it, you get the Google map objects, and you add the marker in Sydney and put the camera there. But we would never do this in our application, isn't it? We would like to apply some structure so the code is more testable and so on. So let's just do a simple abstraction first. Let's just do a really simple MVP where you have your presenter, you have your view, the activity attached itself to the presenter, and then when the map is ready, the view will let know the presenter will apply some business logic and call the view. Simple, easy, yeah. But what happened here? Let's take a look on how this structure looks like right now. So we have an activity, we have the view, and we have the presenter. And now we have these classes that are like the common classes that we would use in, that are property from the Google Maps library or even the location service on Android. So if we start looking at them, where they are used, they start to be used a bit everywhere. But now let's add some more stuff. So we put some repositories where we're going to get like our data, so places, search, and so on. And we are just going to use lat long there because it's easy, you know, like you just give the object and that's it. We start putting more and more things. Then we got another repository, we got another activity, another view, and we start putting all these classes everywhere. What happened right now? We have a nightmare if we want to refactor this. So let's take a look at the first principle. So single responsibility, what does that mean? So it means that the component should not do more things than it's supposed to be. To start with, maps are rendering something on the view. So do not put maps in a different layer. Maps belongs to the view layer. And as well, do not spread those classes all around the application. These classes are for the map, so it belongs to the map view. And do not try to contact this map from other points. It's really common to just contact the map fragment for several classes, and then we end up as well with a mess. In general, you just need to abstract the map in a way that is only accessible from either your presenter or your view model. So let's go back to our example. And on this case, what I did is putting it into a view model from the Android architecture components. So first of all, this view model only gives live data of list of map items. This is the single truth. This is what the map needs. They need to know what to render, and this is what is giving it. So then finally, the view model will just attach himself to data sources. So it will whoops. It will go into the repositories, and every time it changes, it will call this update items method, and we compose all the list of items to show in one single method. So we get the data from the repositories, we convert it into map items on a descriptive wave, and we put it into the live data. So then, on this other side, the view actually only needs to observe this list of items. So this is like normal view model stuff. If you have worked with that, we get the view model from the providers, we initialize the map, and once we get it, we start observing this list of map items. So every time that the list of map items changes, this observer will be called. And what do we do? So we know that these lists of items are the single source of truth. We don't know what on the view was there before, so first of all, we clear everything. And then for each new map of item, we try to represent it, and this is where like the actual map code goes. So we convert it into whatever it is telling us to do. So in this case, a marker that describes a place, and we add it to the map. And now most of you would be like, oh, clear the map and then add everything every time that changes? That sounds bad, isn't it? We will get there. So I've talked like about the single source of truth before. How we can guarantee that? So this is where like the other key principle comes, so immutability. Why is that so important? It's a way to avoid like your classes and your objects and your fields change when you are not expecting that. So it is really common to use the map objects directly in your code, but you don't. Sometimes actually these objects are mutable, and even they contain native code inside. So it is a common mistake to use them, and then you are in situations where you thought that one class had selected the marker, but the other class has the same instance, and it's actually not selected, so you get into an inconsistent state. So it is really important that the items that you are describing for the map are immutable. As well, it avoids possible issues with concurrency, and they are easier to test, of course. So let's take a look at how are we doing immutability here. So this is Kotlin. Data classes and Silk classes, they help a lot with that. So here's like a really simple way to just, for example, describe a point. So we have our point as a Silk class. It can be a marker, and then we end up describing that this is a search, and then we add the immutable fields on it. Because of the data classes, you get a lot by default, and with the Android extensions, you even get like parcelable classes easy. So back to our example, we had our view model that had an immutable live data. So we are not exposing the mutable live data. This is inside on the private class, meaning that no one else outside of this class is able to modify the content of this live data. Also, every time that we create a new object, we create a new immutable object that it cannot be modified. And finally, we are posting into that immutable live data a new immutable list. So there is no way that any other part of the code will modify that part, and we know what we have there. A note here, of course, every time that you recreate a list, so every time something changes, you are recreating a full list, you are recreating new objects, so that can lead to performance issue. So it is important to keep an eye on that and then apply optimizations. But for the sake of the example, we will not go into that. Finally, so we talk about the single responsibility classes. We talk about that there is one single source of truth that is immutable. But now there is something missing that is really important. So where all this data come from and how it flows through your application. So on the example that we had before, we have repositories that define the source of the data. So a search item, for example. This search item goes into the mapping model. And this is the one who knows how to convert this search item into something that the map might understand. Finally, that it, as we saw, it creates a list of items, then the map fragment is the one who observes this. So it goes all the way to there. So that is pretty simple and easy. There is no like back and forward. But now let's come on to the topic like, okay, we have another view, some fragment, that wants to, when I press the button, interacts with the map and change the camera or something. So maybe first attempt would be to do that. But that is, of course, wrong, because that will be breaking the first principle. We should not contact the map on different points. The map is only listening to the map view model. So let's just create another view model. That is the common thing. So this view model then, for example, could just talk to the map view model. That could be as well a possibility, but I think it's not the best way, because then we will end up with this map view model like that is being contacted from everywhere. Instead, we would add another concept, that it's interactors or use cases. Probably you have talked where you have heard about that. This component basically helps with the communications between different view models. So our fragment will tell the view model, hey, there's its button press, this will go to the interactor, and finally will go to the map view model where we'll apply the logic according to the new state where we are. And that, of course, then will change on the map, for example. And to finally, on this flow, we are missing the other way around. So when something modifies actually the map fragment, this is simple. We just go to the map view model, and the map view model forwards it to the interactor, so the interactor can notify other classes that might affect it. So hiding a view, showing a view, etc. So let's look at the result of all this. You remember at the beginning, we have all the map classes going everywhere. So right now, after applying these concepts, we see that actually all the classes are only consolidated into the map fragment. So there is no, so the rest of our application is agnostic, is map agnostic. They don't know about if we are using Google Maps or Here Maps or wherever. It's only the map fragment that knows how to represent it, and actually then we could just swap this implementation. So let's now go back to some improvements. As I mentioned before, you saw this piece of code. It's not the nicest one. Like, we just imagine we have 100 markers and we clear every time and recreate all of them and put them inside. So how can we make that better? Let's forget 1 second that we are dealing with maps. So what do we have here? We have a view that is listening to a list of items, and we want that every time that this list of items changes, we want to add the new ones, we want to remove the ones that they are not there, and let the ones that they are there without touching it or updating if some field has modified. Does that sound familiar? I would say so. It's an adapter pattern. So we can actually wrap all these map implementation into some sort of adapter. And here we would just, on the view, we would just simply create the adapter. Once we get the map object, we pass it to the adapter, and we attach this adapter into the source, into the observing the list of map items. So moving to the adapter code, here, as you can see, I am using a library. It's called MapMe. It provides the adapter pattern for the maps out of the box. It's the Kotlin library. It's pretty nice. Still, you could make your own in-house solution. It's not too difficult to do it. But for this example, we will focus on this library. So what do we have? We have the adapter extending the Google Maps, because we are using for this example the Google Maps, and implementing the observer of the list. So every time that the list changes, this method will be called. We get the new items, and we have the old items. So now we have to compare. This library actually offers a utility. Well, it offers that we can use the recycle diff utils that helps dispatching changes on adapter. So we will pass the new list and the old list into the diff util, and this will tell us which items has to be updated, which item has to be removed, and dispatch it to the adapter out of the box. And then we just need to implement the methods of this adapter. So trivial, we have item count. We say how many map items do we have. And then for each item that it needs to be created new. We will get this method, and here is where we will create our so-called annotation here that can be from a marker, from a polyline, whatever you need to do for your implementation. And then there is the last method that will just tell when something has to be updated. For example, in this case, we will update the position of this marker and icon. So that's it. Every time the view model dispatches a change that comes from any other source on the repository, it will generate a full list. It will go to the adapter, and the adapter will actually change what is actually need to change. So if we have a list of 100 items and then we only have 99, but the 99 are the same, we will not clear the map. It will just literally just remove the one that is not on the list anymore. So that's pretty much it. I created example, a showcase. I open source it. It's really basic. It actually have 2 repositories, as I showed before, that they are delivering like fake data, one for places and one for search. And then we have this view model and the adapters for each of the map providers. In this case, we have Google Maps, and we have here Maps, and then finally we have Mapbox. And the only difference on the code is on the adapter. All the rest of the application is the same code. So we are able to switch between different providers really easy. And this can be really beneficial, not only for your own code to be clean and so on, as well when you, for example, try to publish things onto the Amazon that they were not allowing first the Google Maps. So that's it. Finally, yeah, sorry. So we just covered the basics here, like how the map, the markers, but we have a lot much more in maps. Maps are complex. You have camera states, you have map gestures, you have complex items like polylines, routes, and maybe complex interaction with the map. So there is still a lot to cover, but we just need really to apply the same principles that we have seen here, and the important part is like this, to have this abstraction from the rest of your code, so it keeps more clean. So thank you, everyone. I hope that you enjoy.